Lesson 8 of Unit 3 addresses pipe design in Civil 3D. In Exercise 1, you create a pipe network. In Exercise 2, you learn how to draw pipes in Profile View. In Exercise 3, you edit the pipe network. In Exercise 4, you label the pipes. And then in Exercise 5, you design the pipes in that you calculate pipe sizes and invert elevations. A pipe network is a system of related structures and parts. So if we go to Civil 3D, you can see here in Plan View we've got a pipe network. And in Prospector, if we expand pipe networks, here's your network here, Storm Sewer 1. These are the pipes in the pipe network. And these are the structures in the pipe network. And here are the parts in the profile view as well. When you create a pipe network, you lay out the pipes in Plan View, and the pipe and structure rules are used to calculate the rim and invert elevation. So you have rules that are used to calculate the rim elevation from a surface, and then the invert elevations are calculated based on depth and slope criteria. And using the Pipe Network Layout Tools toolbar, you have a number of commands that allow you to choose pipes and structures to create your pipe networks. And you essentially lay out the pipe network in Plan View. And your pipe network appears in Prospector. There's your pipe network, and then it's categorized into your pipes and then into your individual structures. So if we were to open up a drawing here, we could lay out a pipe network in this drawing, and it's a very simple thing to do. There's the surface representing the design top surface of the roads. We could first suppress the display of that surface. You can suppress the display of that surface, and then under the Create Design tab you can go Pipe Network Creation Tools. This could be called Storm 1. The surface name is FG Roads Top for the rim elevations, and the alignment name could be Cedar Cove if we're running it along here first. The structure label style in Plan View is name only, and the pipe label style is name only. And here is your Network Layout Tools toolbar. You choose your structure, perhaps a 48-inch structure, and a 18-inch pipe, and you can create pipes and structures, and you can pick locations to create your pipe network. And that pipe network once again appears in Prospector under Networks, and there's the 2 pipes and the 3 structures. In Exercise 2, you draw the pipes in the profile view. And to draw pipes in profile, you simply pick your pipe network and the contextual menu, draw parts in profile, and you can then pick the profile view, or if you wanted to, that will draw that single part. You could then select a single structure and a single pipe and right click and select Similar to grab your entire pipe network, and then draw parts in profile, and that would then you'd pick the profile view, and you can see how the parts have been drawn in the profile view. In Exercise 3, you learn how to edit a pipe network using some of the graphical editing tools and also some of the tabular editing tools. So you can see you can edit the data in a table in Prospector, or you can even go to a single part and go to Structure Properties here, and under the Part Properties perhaps we want to change this sump depth, which is quite deep here, to 0.5 feet or 6 inches, and click OK. And you've modified that sump depth. And all of the properties for a pipe and structure are displayed here, so we can change grades, invert elevations, and so forth. So all that information is available. You also have grips, and also if you move a part in plan view, a couple things to observe here. Notice that when I move this manhole, the pipe follows it, and also notice when I move the manhole, let's move this one here, watch what happens in the profile down in this area. You can see how it recalculates the position of the manhole for the profile. So that's nice to be able to do that, and the rim elevation is also updating. So if I move this manhole here, which is the middle one, let's move that over to here, you can see how it updates. In exercise 4, you learn how to apply labels to your pipe network, and once again, as is with all Civil 3D labels, they are dynamic. And then finally in exercise 5, you use the HydroFlow storm sewers extension to design and size your pipes. And essentially you export the data from Civil 3D to HydroFlow. You analyze that in HydroFlow by putting in flow rates, size the pipes, and then you import it back to Civil 3D. So you lay out the pipes in Civil 3D, you export to a storm sewers project file, you import the file into HydroFlow, storm sewers, calculate the flows, or import the flows, or input the flows, size the pipes, calculate invert elevations, export the data to a project file, and then import the designed pipe network back to Civil 3D. So let's go through that. So if we close this drawing down here, let's close this drawing. And here's our pipe network. So what we can do is we can pick the pipe network, and we can storm sewers, export to file, and there's the storm sewer file, and the file will be storm 1 layout. It'll be the layout file, not the design file, but the layout file, so we'll overwrite that. Then we can launch the storm sewer application. And this will launch a separate application for Civil 3D. And this is the HydroFlow storm sewers extension. And once that application launches, we can then just make sure that our units are the US customer units. Let me just check the design codes, and that looks good. We can then open a project, and it will be the layout file that we just created. And now we can go to the, so here's all the information on the pipes. So now we can go to the pipes tab and import some flow rates. So if we just go back to the PowerPoint, we're putting a half a cubic foot per second into each pipe. So let's do that. So this will be 0.5 here, and then 1, 1.5, 2, and then 2.5. Now as you'll notice, all the pipes are 12-inch pipes. Right here, the line span in inches. And if I go back to Civil 3D, you can see that these are all 12-inch pipes. Everything is 12-inch all the way along. So if we go back to HydroFlow here, we can now that we've put in the flow rates, we can save the values by clicking the OK here. And now we can run the design, and we'll do the full design. And the starting will be, hydraulic grade line will be the normal. And if I click OK, all those pipes have been sized. So now here's the line 1. At the bottom is 18-inch. If we go next, we've got a 12-inch at the very top, and then if we start going down, 12, 12, and then a 15, and then the 18. So now you can see how these have been resized here from 12 to 12 to 12 to 15 to 18. I can now export or save the project as the design file. And we can now close HydroFlow Storm Sewers extension. And then what I can do is, if we go back to the ribbon, we can import from file, and that will be the design file that we just created here. And we will update the existing pipe network. It's going to take a moment to bring all that information in, but essentially it updates the pipe network with the updated invert elevations and the updated slope values based on the flows that we put into HydroFlow Storm Sewers extension. So let's have a look, and we should have 3 12s and then the 18 and 15 and the 18. So here's the 12, there's the second 12, there's the third 12. Now we've got the 15-inch right here, and then we end off with the 18-inch. And that's also reflected here. There's your 12 to 15 to 18. So everything's been resized in Civil 3D. So that concludes the last lesson on pipe design in Unit 3, which is for land development.